All right, everyone, welcome back to AI Paper Podcasts. Today, we are diving headfirst into a fascinating paper that dropped just this month, February 2025. It's called Scaling Pre-Training to 100 Billion Data for Vision Language Models. And it's tackling a question that's been on a lot of our minds. Does model performance really just keep getting better the more data we feed it?
It's a question with huge implications, especially in the world of vision language models, or VLMs for short. These models, which can understand both images and text, are becoming increasingly powerful, and we're always looking for ways to push their capabilities even further.
Exactly. And this paper does that in a big way, using a dataset of 100 billion image text pairs. That's WebLI 100B, a dataset 10 times larger than anything we've seen before. So for those of you tuning in for the first time, or just looking for the TLDR, let's break down the key insights right off the bat. The researchers took a few different sizes of cinglet models. Think of them like different brains for the AI, some smaller, some larger. They trained them on various scales of this massive WebLI dataset, going from 1 billion pairs all the way up to that monstrous 100 billion. And what they found might surprise you.
While scaling to 100 billion did improve performance in areas like cultural diversity and understanding multiple languages, especially those with less data available, the gains on those classic Western-centric benchmarks, your ImageNet and COCO captions, were pretty minimal. It seems there might be a limit to how much these models can benefit from sheer data size for those tasks.
And get this, they even tried filtering the data first, using something called CLIP, like a quality check. But that actually made the AI worse at understanding different cultures. It raises some tough questions about how we approach AI training and whether our current methods might be accidentally filtering out valuable information.
So while going bigger isn't always the answer, this research highlights the importance of massive datasets for building AI systems that are more inclusive and representative of the diverse world we live in. It's definitely food for thought for anyone working in this space.
All right, now that we've got the highlights out of the way, let's unpack this paper for those of you who really want to get into the nitty-gritty. And trust me, there are some fascinating details in here.
Absolutely. You know those scaling laws we always hear about? The idea that model performance increases predictably with data size? Well, this research puts them to the test in a really significant way.
They weren't messing around. Using cinglet models with VIT architectures, VIT-B16, VIT-L16, and VIT-H14 to be exact, they trained them on this massive WebLI dataset scaled at 1 billion, 10 billion, and then that crazy 100 billion image text pairs.
And as we alluded to earlier, the results on common Western-centric tasks, those benchmarks we all use like zero-shot image classification with ImageNet, CFAR 100, and Oxford the Third PET, weren't exactly mind-blowing.
Yeah, going from 10 billion to 100 billion pairs showed minimal performance gains. It really makes you wonder, is there a point of diminishing returns when it comes to data size for these particular tasks?
And it gets even more interesting. Even when they projected performance with unlimited compute, using those very scaling laws we keep talking about, the differences were still statistically insignificant. So maybe 10 billion IS the sweet spot. At least for now.
It's a fascinating twist, right? Yeah. We're so used to the idea that bigger is better when it comes to data, but this research suggests that it's not always the case.
And that's just the tip of the iceberg. Buckle up, because when we start looking at cultural diversity and multilinguality, things get really intriguing.
Okay, I'm all ears. Tell me more.
Remember that Dollar Street benchmark we mentioned earlier? The one that tests how well a model understands images from different cultures? Well, on that benchmark, the models trained on the full 100 billion data set showed significant improvements.
And we're not talking about tiny gains here.
No, we're talking leaps and bounds.
Like VTL and VITH, those models saw jumps of 5.8% and 5.4% respectively on the Dollar Street 10-shot classification task.
That's huge EE compared to the tiny improvements we saw on the Western-centric tasks.
It's almost as if those models, when trained on that massive data set, suddenly developed a whole new level of cultural awareness.
That's a great way to put it.
And to really drive this point home, the researchers visualized the attention maps of models trained on different data sizes.
And it's fascinating to see the differences.
Right. You can literally see how the 100B model is picking up on subtle details that were completely missed by the models trained on smaller data sets.
For example, remember that image of the Igorot dance from the Philippines?
Yes, that was a striking example.
The 100B model was able to zero in on the intricate patterns of the traditional decorations, while the smaller models were more focused on the overall scene.
It's as if the 100B model was able to understand the cultural significance of those decorations, while the other models just saw them as background noise.
Precisely. And there's another great example with that igloo image.
Oh yeah, that one was interesting too.
The 100B model was laser-focused on the structural details of the igloo itself, while the smaller models were more distracted by the surrounding landscape.
It's like the 100B model understood that the igloo was the heart of the image, the element that truly conveyed the essence of that cultural context.
Exactly. And when we look beyond images to language, the same pattern emerges. The researchers used the cross-modal 3600 benchmark, which tests zero-shot retrieval in 36 languages, and found that the improvements were especially pronounced for low-resource languages.
Languages like Telugu, Bengali, and Swahili really benefited from that massive 100B dataset.
It's as if the model was finally able to grasp the nuances of those languages, unlocking a whole new level of understanding.
This has massive implications for building AI that can truly understand and respond to the diversity of human language.
It's a step towards creating AI that is more inclusive and accessible to people around the world.
Which is incredibly important, especially as AI becomes more integrated into our lives.
Absolutely. But we also have to remember that data scale alone isn't a magic bullet.
Right, and this paper makes that abundantly clear with its findings on data filtering. They use the CLIP L14 model to filter the raw data down to a 5 billion paired data set.
And what they found was really interesting.
Tell me about it.
While filtering did improve performance on those Western-centric tasks we discussed earlier.
The ones where scaling didn't make much of a difference anyway.
Exactly. But filtering actually had a negative impact on the cultural diversity and multilinguality benchmarks.
It's almost as if those filters, while well-intentioned, were inadvertently screening out the very data that contributed to a more inclusive and culturally aware model.
That's exactly right. It really makes you question whether our current approaches to data filtering might be doing more harm than good.
Especially when it comes to building AI that is truly representative of the world's diversity.
It's a complex challenge, and one that this paper brings to the forefront of the conversation.
So we've seen that scaling to 100 billion image-text pairs can lead to significant gains in cultural diversity and multilinguality. But what about other tasks? Did they explore the transferability of these models to other domains?
They did. They tested the models on PalaGemma, which is a benchmark for generative tasks.
And what did they find?
The results on PalaGemma were kind of mixed bag, to be honest. They didn't see consistent gains from scaling the pre-training data for those generative tasks.
So it seems like the benefits of that huge 100 billion data set might be, more task specific than we first thought.
Yeah, that's right. It's not a one-size-fits-all kind of thing. We got to carefully think about the specific tasks that we're trying to achieve, right? And choose our data and models accordingly.
It's like, well, anything else in AI,
right? There's
no magic bullet, so to speak. We got to be smart about how we approach these problems.
Absolutely. And that's one of the things that makes this paper so valuable, It's not just showing us these groundbreaking findings, it's also making us ask these important questions about, how we move forward in AI as a whole.
It's a wake-up call, in a way, right?
Yeah.
Pushing us to think beyond those, traditional metrics.
Yeah.
And consider the wider impact of the models we're building.
Yeah, for sure. It's a call to action, really, for the whole AI community. We need to work together, to come up with new techniques and benchmarks and ways of evaluating models that prioritize, both accuracy and inclusivity.
And that brings us to another interesting point they make in the paper, right? This idea of language rebalancing. They noticed that certain languages were, underrepresented in their data set.
Oh, yeah, for sure. That's key. Especially when we talk about building truly multilingual models. They found that, those less common languages, they only made up 0.5% of the raw data, which, let's face it, isn't nearly enough to really capture all their complexities.
Right, exactly. So they kind of took a proactive approach.
Yeah.
And upsampled each of those languages to a fixed 1% representation. It's it's giving those languages a boost in a way.
Yeah. And the results were pretty promising. This rebalancing, it led to some noticeable improvements in how the models performed on, benchmarks that were designed specifically for those less common languages.
And here's the cool part. It didn't sacrifice performance on those high resource languages. The overall performance on that multilingual benchmark, it actually got better. So that really tells us, that having a more balanced data set is beneficial across the board.
Yeah, no doubt. It shows how important it is to think about representation at every stage of the whole AI development process, right? From data collection to pre-training to evaluation. We got to be asking ourselves, are we truly representing that full spectrum of human language and experience?
It's a question we should all be thinking about, right? In the AI community, I mean, it's not just about building models that ace those benchmarks. It's about building AI that's fair and inclusive and accessible to everybody.
Couldn't agree more. This paper, it reminds us that we've got this responsibility, to build AI that benefits all of humanity.
Well said. And on that note, I think it's time to wrap up this deep dive into scaling pre-training to 100 billion data for vision language models. It's been a great discussion, and I hope you all learned something new today. Be sure to check out the paper for yourselves and let us know what you think in the comments. Until next time, keep exploring the cutting edge of AI.